So we're talking about compressive strength today. F prime C, which unfortunately the meaning of this was lost, and I think it was originally created by the Egyptians centuries ago, but it was lost through time. That's not true.
That's not true, John. Come on.
What does F prime C do?
F prime C, well, what it actually is compressive strength. Strength is the stress at failure. So Whitney, when we run tests, how does that go?
How does that go? You put it in the compression machine and you place a load on it, and then at some point it becomes catastrophic and cracks.
So we take that maximum load, P, we divide it by the area of the cylinder, that's stress. The stress at which something breaks is strength. So we get compressive strength. We call compressive strength F prime C. And that's kind of left over from last century. Here's the cylinder, just to give you the idea. So as Whitney said, we put the load on the cylinder, it breaks, we take that maximum load divided by this surface area, that gives us stress. The stress at which it breaks is the compressive strength. F prime C comes sort of from last century. The F looks a little bit like stress, but it was easier to type on a typewriter, so you didn't have to change the ball on the IBM. C comes from compression. Prime comes from our friends over on geotech. We want to think of this as effective stress. We stick the prime on there for that. F prime C.
Dude, that is so awesome. Why do we care about compressive strength? I mean, growing up in the concrete industry since I was a pup, that's all we cared about was compressive strength. I mean, I don't care if you're a contractor, a concrete producer, engineer, architect, standard specifier, writer. Compressive strength is used throughout all of our major ACIs and ASTMs as well as design. Not only for quality control, but also for design or practice and design.
Right. The idea of stress in general is it's on a unit basis. It's the pounds per square inch. And so you think, well, I take this cylinder, I can make that into a big column on a highway. I could make it into anything else. It's geometry independent. It's size independent. So the idea was we can miniaturize the field case in the laboratory, get the strength or the stress, and blow that up to the real size field.
I have a question for you, David. Why is it that in airfills they prefer flex over compression? Because that is the only, I would say, part of the industry that wants flex. Compression is not a big deal for them. They want the flexural strengths always.
Yeah, there's no question. We see that all the time. We also see that in the highway pavement.
Oh, really?
They can either specify compressive strength or they can specify flex. But getting back to what was actually your question, I mean, we're talking about pavement here. So when something rolls over that pavement, it has a tendency to flex it.
Sure.
And so the weakest part of that is it's going to have a tension stress on the outside fiber. We want to make sure that that tension strength is enough to bear the load as it rolls over.
Okay.
So again, it's the idea of miniaturizing the field case in the lab by taking a beam in the lab and bending it. It's like a pavement in the field with a wheel going over it.
Okay.
One of my biggest issues with ACI 318 and compressive strength is that compressive strength is used to determine a lot of other properties, hardened properties of concrete, like modulus of rupture or flexural strength, or splitting tensile strength, where you can take your compressive strength and take the square root, multiply it by a factor, and supposedly get the modulus of rupture, modulus elasticity, so on and so forth. What are your thoughts on that?
It would be nice if every concrete mix was the same. You know, wouldn't that be wonderful?
Wouldn't it?
Wouldn't that be wonderful?
We wouldn't have a job, by the way.
Well, that's true.
Not quite so wonderful.
It wouldn't be so wonderful
as
for
we
me.
thought.
As I originally thought, that's true. So these correlations were built out of, graduate work, graduate studies. They're built out of laboratories and whatnot. So they're probably a reasonable rule of thumb, but you need to be careful with those. Some of them go towards folklore. Some of them go towards rule of thumb.
Sure.
Some of them go closer to science. But you have to be careful with them.
Oh, totally. Do you mind redoing that flexural discussions with this awesome beam?
Sure. Thanks, John, for the beam. So here we have just an ordinary piece of foam. And again, to get the visualization of it, we're going to roll hold that other
I
hand.
would love to.
We're gonna roll a plane or a truck or something over it. So this is the wheel. And look at that. See how the squares are a little bit bigger at the bottom and a little bit smaller at the top? So this is tension. This is compression. Concrete is weaker in tension, stronger in compression. So the stress at which this outside fiber fails is the flexural strength. And so we're concerned about flexural strength to look at wheel loads on pavements.
That's awesome stuff. Well, I think we did a great job today looking at why we care about compressive strength.
Sure.
I learned something new. I mean,
I did too.
that was pretty cool. Thank you
Just
for that
got another
education.
wrinkle.
Yeah, I like the fact that the F comes from the ball and the IPM
Yeah.
typewriters.
Yeah.
It sort of kind of looks like a stress symbol, but
Totally.
Yeah,
but it's really just because it's easier to type.
I like that.
Do you know what a typewriter is? A
I
typewriter.
know what a typewriter
You're a millennial. How am I supposed to
I'm
know?
a millennial.
Dude.
You stop. Okay.
The definition of a millennial is
Stop
somebody
talking
who
right
came
now.
of age in the millennium. Or in the millennium. Millennium.
You're only 5 years older than me, so don't get.
I was just trying to help you out. Maybe you've never seen a typewriter before.
I have seen a typewriter.
In a
I have
museum?
worked on a typewriter.
Ow! It's on video that she's a
Good.
typewriter.
You're running that valve all the time. You can't stop. What do you think, David? Who's right?
I think we should end this right here, is what I think. I think that's a good discussion on compressive strength and flexural strength. And I hope everybody gets the idea that we miniaturize the field case in the lab and that things are good here at Intelligent Concrete.
David likes to be Switzerland. He doesn't like to choose sides.
Okay. Bye.
Bye.
Bye, everyone.
End blog.
David out.